Testing this microphone. There we go. Yeah, okay. Okay, welcome everybody. We are ready to get started. Please quiet down your conversations, wrap them up. All right, we are here for the breakout session on the early science program. Welcome. We start, as we always do, with reminders that we do have a code of conduct, that harassment and unprofessional conduct is not permitted. As you may have seen, you will be removed from the Slack space if you use inappropriate language. So if you do experience or witness any other instances of violation in the future, please reach out to our code of conduct contacts. Little reminders about COVID. If you're not feeling well, please wear a mask and isolate. And then reminder of the social battery buttons. If you see someone wearing a pin like this, act appropriately. As reminders for Zoom participants, please mute if you're not currently speaking. We're going to have everyone speak into a microphone during question sessions. There will be microphone runners. So if you're going to ask a question, wait for the runner to hand you the mic before you ask it. Questions are welcome in the Zoom chat and also in the Slack channel that's dedicated for this space or for this session. All right. Let's move on. Let's talk about the Rubens Early Science Program. Hi, my name is Melissa Graham, lead community scientist for Rubin Observatory. Hi, you met me this morning and you get all the emails from me. Happy to be here. All right, Early Science Program. For Rubin Observatory, early science is defined as any science that's enabled by Rubin for its community through and including the first data release 1 or DR1. The plans, and as they evolve, they're always updated. The plans for the early science program are all in Rubin Tech Note 011, RTN11. That can be accessed with the short link ls.sd/RTN-011. It contains the timeline for the implementation of this program, which data products you can expect to come out when. It is regularly updated, as I mentioned, and it's also DOI citable. So this is the thing to cite in your grant proposals, for example, to say, Rubin's going to make this by this date, and you put it in your grant proposal. There's a category in the Rubin Community Forum that's dedicated to discussion and answering questions about the early science program. And I think pretty much everything that's going to be said here today is also in that document. Oops, too fast. All right, the scope of the early science program, everything that it encompasses, starts with the data previews. Data preview 0, 1, and 2, or DP0, DP1, and DP2. DP0 was based on simulated LSST-like data. DP1 was based on data from the commissioning camera, LSST ComCam data, and DP2 is based on LSST CAM commissioning data, so slowly scaling up through these data previews. Another aspect of the early science program is template generation for alert production. This uses LSST CAM commissioning data prior to the LSST start and after as well. And then to incrementally make templates also during year one and before to maximize alert production. Having the World Public Alert Stream is another component of the early science program. That is providing real-time data for transient, variable, and moving sources. And the alert stream itself, like how many alerts per night and the regions on the sky, is scaled up continuously through commissioning and also through year one. The prompt process visit images, making them available, is also within scope of the early science program. Sometimes you'll see these shortened as PVIs, but it just means promptly processed visit images. These will be made available later this year. And until data release 1 is released, all of the prompt process visit images that are being made available, like in real time with that 80-hour embargo, will be accompanied by direct image source catalogs as well. And the motivation for sending those two out together is to enable static sky science outside of the data previews. And the reason why I make this distinction is because once we're sort of in more regular operations post data release 1, the prompt process products are entirely different image analysis based. And so they wouldn't normally just have source catalogs go with them. They just have different image analysis products. But in the lead up, they will come with those direct image source catalogs. And then once we're through all of those, we will be at LSST Data Release 1, DR1, which will be based on the first year of LSST data. Also within scope of this early science program is all the user resources to go along with enabling people to do science with all of these different types of data. So there's a data preview era, Rubin Science Platform, and documentation and tutorials to go along with all of these things. And most of what I'm going to talk about today is all of just the details of all of that. So the status now that we've covered scope, the status of the early science program, the LSST itself was declared started on June 29th of 2026. And as you'll hear about all this week, work to improve system performance and deliver early science is continuing. The status of the data previews, DP1, DP0 was released years ago. It's still available. But more importantly, DP1 was released last year in June 2025, and it is also going to remain available until data release 1. The public alerts, they began in February of this year, and now on order of 100,000 alerts per night flow to the 7 alert brokers. In terms of the target of opportunity, which I didn't mention, but is also within scope of the early science program, the first trigger from an IceCube trigger was executed on July 9th. And there's a community post that describes what were the observations that were done for that particular trigger, how it worked, that kind of thing. Early Data Preview 2 has been already released today, so the slide is a little bit behind reality. Everything worked fine, and you should be able to access it now if you go to data.lsst.cloud. And we'll have a lot more information about EDP2 in future slides. Continuing with status, the prompt products database is expected later this year, September to October 2026, and then the full version of Data Preview 2 and the promptly processed images are expected October to December 2026. So that is kind of the timeline for all the different components of the early science program. And alongside all of this, of course, the user resources, data access via brokers and also via the Rubin Science Platform at data.lsst.cloud, plus documentation, tutorials, virtual seminars, a process for issue resolution, which is the forum. All of this is continually scaling up with each new component of the early science program. To look a little more in depth at some of these points about the status, you will notice right away that Data Preview 2 has been split into an early and a full version, where the early version of DP2, which is what was released just like an hour ago, are the deep COAD images and all of the catalogs. And when I say all catalogs, I mean that's literally all of them. It includes metadata and the measurements that were made on the visit and difference images, even though those visit and difference images themselves aren't part of early DP2. All of the difference image analysis, all of the solar system tables for time domain science are also available now with early Data Preview 2. For full Data Preview 2, all that's doing is adding the remaining images. The raw, the visit, and the difference images will be made available October to December of this year. The challenge there, which I'll have another slide on, is the full end-to-end integration of the hybrid Rubin Science Platform that's combining USDF-hosted data and cloud-hosted data together. So there's a bit of a challenge there, and that's what has driven the split of Data Preview 2 into an early and a full version. Looking at the prompt products database and prompt images, those two things, so together they make up all of the prompt data, all of the prompt products. Those have also been split apart into the PPDB, the prompt products database itself, that is alert. Basically, it's the same data that goes out into as the alert packets, but it's in a queryable database that gets updated every 24 hours. The target for putting that online for you is September to October of 2026. Where the challenge there is solar system data ingestion and also implementing measures to control the cost of queries to not allow users to make very inefficient, very expensive queries. So trying to limit the system to kind of guide users to only make efficient and cost-efficient queries. So that's September to October 2026. And then the prompt images themselves, the visit and difference images that are coming out of the prompt pipelines, plus the direct source tables that I mentioned that go along with the visit images, the promptly processed visit images, they're facing the same challenges as releasing the visit and difference images for Data Preview 2. And that's the full end-to-end integration of the hybrid RSP. So their time scale, the October to December 2026, is the same time scale as the full Data Preview 2 for that reason. So hopefully that illuminates a little bit why things are being done in multiple stages over the course of this year. And just to say a brief extra thing about why these LSST, sorry about the typo, LSST cam images are expected October to December 2026. New high bandwidth gateways were recently deployed to serve the LSST cam scale images from USDF to the cloud, where USDF is the US data facility, which is where all the data lives and all of the processing is done, to the cloud, which is where you're going when you go to data.lsst.cloud to actually do your data access and do your science. So it's that link there that the gateways have been installed, and then further testing is still needed to get everything up and ready to really serve the full DP2 release. Okay. Hi, Frosty. Hi, welcome. Yes, it got mentioned, and it's going to get a better slide in a moment. Yes, the EDP2 release. We'll get a nice slide in a moment. Yes, yep, okay. Right, so for early data preview 2, the deep COAD images are being hosted right in the cloud so that they do not have the same issues in service as the visit and difference images. This is another sort of picture. This comes straight from RTN 11, where you can see each of the data previews up to data release 1 and how new types of image products are coming online each time. And this basically just shows between EDP2 and DP2, it's just the raw, the visit images, the difference images, and also the templates that are not there in EDP2, but will be there for full DP2 later this year. This is the timeline that I'm sure you've seen before that kind of shows you where we are. Where we have today is the day of release of early data preview 2, PPDB coming up to be available in the coming months, and then the full DP2 by the end of the year. And this just kind of gives you an idea of what is coming. All right, so now I do want to get a little bit more in depth into what are the data products that are coming out as part of the early science program in these data previews. So we're going to start by just going a little bit back in time to data preview 1, which was released last year at the end of June. And this was all data obtained with the LSST commissioning cam, LSST ComCam, or sometimes we just call it ComCam. It was a single raft of 9 CCDs, and it was on the telescope over 7 weeks, right at the end of 2024. It observed 7 fields across the southern sky to support a range of science goals. And it observed these 7 small fields with different cadences, different filter combinations, and ended up with different co-added depths as well. All of this has been available for the past year. It's very small in terms of data volume, but it was already very complete in terms of the different types of data products that were being made available from it. So it is still a good first testing ground if you just want to sort of test queries. All of the documentation remains up, the tutorials are still available, and the data set itself is still available. You can find all of the documentation and tutorials for Data Preview 1 at dp1.lsst.io. And you can find the tutorials in the notebook aspect of the Rubin Science platform, where they live in a drop-down menu. Here, I do want to pause and mention that we do have a help desk. It is an open, modern help desk, and it is the Rubin Community Forum. It's available online at community.lsst.org. Anyone can make an account in the Rubin Community Forum and ask a question. The benefit, of course, of having a more open model instead of a more traditional closed help desk is the ability to crowdsource solutions from your peers. So often people will post a question in there, and sometimes another user can answer it before we get to it. But Rubin staff do always see every single question that is asked in the support category. We do monitor it every day, and we make sure that questions that end up there do eventually get solved. So everyone is encouraged to ask their questions here. Students too, you're especially encouraged to ask questions, report issues that you're having with using the Rubin data, and we will make sure that we get that solved for you. There's a couple of other uses of the forum. You can keep up to date with staff posts in the news category. And then so this is a screenshot of the community forum. And if you scroll down, you'll notice other categories below the support category, like science and science collaborations. And those are more just like open discussion categories. If you're looking to find collaborators or to share your work with people, you can do that in those categories instead. But all questions go in support. As for citing the data preview one as a data set, there's a web page that tells you all the DOIs that you need. You cite the paper, you cite the data set, which is a separate DOI, and then also individual data sets like the object catalog, for example, has its own DOI. So you can cite exactly the data sets that you used. All right. Early data preview 2, it was released today by people. Yes, yay. This is wonderful. Yusra took this picture of the little room where people were working together and working on Zoom and getting everything set up. And so it is there. You can go and browse it now. If you look in, they're browsing. Frosty has been monitoring usage. And so we saw when Gregory made me the HIPS links and I shared them, and then suddenly usage of the HIPS maps soared, for example. So we've been watching you watch the data today, which has been really exciting. So yes, it is out. And also, yes, the Rubin First Look regions are included in Data Preview 2. It's a very common question. They're there, and much, much more. And that much, much more looks like this. So Data Preview 2 includes about 30,000 visits that were all acquired between April of 2025 and January 6th of this year. In terms of total sky area covered, it's about 15,000 square degrees. And in terms of the sky area covered just by the deep coads, it's about 3,000 square degrees. On this particular image, the heat map in the background is the number of visits everywhere on the sky that's included in Data Preview 2. And you can see little black boxes drawn on there. And those little black boxes represent the predefined sky map of where a deep coad image would be made if enough data was taken in that particular little box. The little boxes are called patches, and they're part of the sky map, which we define as tracks and patches. So before Data Preview 2 was started, those regions of the sky that could become deep coads were decided on. That's why some of the boxes are empty. Is sort of over that observing campaign, not enough images were obtained at the edges to make deep coads there. But that's what this plot is showing. To look at it another way, this is, again, the background in blue is a heat map of the number of visits. Here you can kind of see the lesser populated sky map patches where deep coads don't exist a little more clearly. And then every sort of special field that has ever been named or discussed as part of the science validation surveys and all the deep drilling fields are individually labeled so that you can see, for example, the DDF, the deep drilling field for XMM LSS, although it did get some images, it was not in the original definition for the sky map of where coads would be made. So although it has a bunch of images there, it does not have a coad there. So it's something to be very aware of as you're working with Data Preview 2 and you're querying for images in certain locations. There will be places that do have images, but don't have a deep coad. And I'm trying to explain to you why that is with these slides. If you are a Data Preview 1 user, there is also some minimal overlap between Data Preview 1 and Data Preview 2, and that's what this slide kind of shows you, that Extended Chandra Deep Field South, Euclid Deep Field South has kind of the most number of visits in Data Preview 2 and have sort of decently deep coad images. And then the rest of the Data Preview 1 fields, not so much. So if you're working on a certain kind of science with Data Preview 1, you might be switching fields and doing that particular science in a different field. Later in this week, on Wednesday, I think after lunch, we're going to have a Get Started with Data Preview 2 session where you can actually get hands-on and figure out which field you might want to start your research with and learn just a lot more about it. So for Data Preview 2, processing and co-edition, a few special notes on what has happened. And like I just mentioned, upcoming sessions at the RCW that are relevant to learning more about Data Preview 2. So there are a couple of key concepts for the Deep COAD images, which are different from Data Preview 1. The first thing I've just mentioned many times, that the sky map was predefined. The second is that visits only contribute as inputs to a Deep COAD image if they had a PSF that was relatively circular, so a total ellipticity of less than 0.2, and if the PSF full width half max was less than 1.7 arc seconds. There's also a constraint on the transparency of the atmosphere, like at the time that the observation was taken, such that the effective exposure time for that image, for that visit image, had to be greater than 0.75 for it to be included in the Deep COAD. So this is something else that you'll find as you start to explore the data. You might go and look at the number of visits that are on a certain sight line that you're interested in, and the depth of the Deep COAD might not quite match up to what you would expect from the number of visit images that are along that particular line of sight. And that is why not every visit image was included in the Deep COADs. The other thing to note is that the Deep COADs were generated with cell-based coaddition. So if you take each patch, instead of just combining every image that overlaps even partially, which is what happened with Data Preview 1, and the image right down at the bottom is illustrating all the edges that overlapped with that particular Deep COAD patch. So lots of partially overlapping images were used in Data Preview 1. That gives you PSF discontinuities across the field that are just kind of random, and it just depends on how those images aligned. But when you switch to cell-based coaddition, you take your patch, you make 22 by 22 non-overlapping cells per patch, and then you only use as inputs to each cell visits that completely overlap. So each patch of a Deep COAD has a consistent PSF across it and a consistent depth. It just gives you overall sort of a more consistent Deep COAD image. And you're going to notice this, especially if you use the Deep COADs and you look at the masks have a lot of information. So, I mean, that's what's kind of showing you right here. There is no even sensor edge mask. You don't need it anymore for the Deep COAD. So if that mattered to your science at all, that is one big difference with DP2 compared to DP1. There's also a new image format that improves our interface with FITS and AstroPi. All of the new tutorials for Data Preview 2 have already been updated to work with this new image format. Data Preview 1 images remain in the old format for now. So if you are a tutorial user and you start there when you're trying your science analysis, you won't find anything different. If you try to take a notebook or a code that worked for Data Preview 1 and deals with images, and you try to run it directly on the Data Preview 2 images, it might not work for this reason. So I want you to be aware that image formats have changed. So if you try to read them in, or if you've saved images, or literally anything to do with images, keep an eye out for this and learn to use the new image format. All right, keeping going with Data Preview 2. Here's that sky map again of the Deep COAD. Now before I was showing you just like the number of visits over the field. This is the actual co-added I-band depth. And the point here is just that I-band depth is very non-uniform across the field. Of course, this will always be the case. We will always have deep drilling fields that will be extra deep. During years when the survey is in rolling cadence, there will be stripes that will be a lot deeper than other parts. So the Deep COADs will always be essentially non-uniform in depth across their field, but this at the start, you can see it's extra non-uniform. So if you are doing science that depends on the depth of the location, you're going to want to be aware that as you do your work, fields that are adjacent can have very different limiting magnitudes. That's just my point. This is a plot of the Deep COAD I-band average epoch, so the average date on which the observations that contributed to that Deep COAD were taken. And here again, you can see variation across the field where different fields were sort of completed or observed, got observations at different times. And in particular, because the dark is the earlier time. So back in May, I just want to make the point that some fields have a very early average epoch. And so if you are into time domain astronomy. That's just also something to be aware of, depending on what type of object you're looking at, or if you're looking for, oh, did Rubin detect my favorite AGN in this field? It's not a uniform cadence. So observations were not obtained over all fields over all of 2025 through January 2026. They were obtained sort of in seasons. So be aware of that as well. This maps the Deep Coad I-band average PSF. So this is like the average image quality, which I'm just making the same point here as for the depth. It's non-uniform across the field. So if your science depends on this, know that adjacent deep coads can have different image qualities, different PSFs. All right, all of this, everything I've just told you is available in the Data Preview 2 documentation. All of that documentation effort is still in progress. We really prioritized having a set of tutorials come out over the last couple of weeks. So if you go into the notebook aspect, there will be a lot of notebook tutorials to help guide you and help you learn about the different data products. So all of the documentation is still under development, but it is there. It's citable and it's there for you to search and to query on and to learn about the data products. There's also data release journal article. It is in Rubin TechNote 115 right now. An early draft version of this should be up sometime very soon so that you can cite it with your first EDP2 papers. Right, I just mentioned the DP2 tutorials, which were a particular focus for us. You can find them all in the notebook aspect. Tutorials for EDP2 for the portal and the API are still to come, but when we do have them ready, they will show up at dp2.lsst.io. And in particular, next week, we're going to be holding some onboarding virtual seminars with specific tutorials to help you get started with EDP2. So you can find the schedule for that. It's basically the Tuesday and the Thursday, August 4 and 6. There'll be one morning session and one evening session Pacific time to hopefully serve the global community. So you can drop in on those, get started with EDP2. And they'll be recorded as always. All right. I'm going to pause and take questions on EDP2 and before we switch over to prompt products. So I have my two mic runners, Eric and Steph are here ready to help you ask your questions.
We have one up here too, but we can start with online.
Let's go in room first.
Oh, okay.
Thank you. This is super exciting. I was just looking around on the interactive view of EDP2. And so it's showing pretty coads. And I was wondering how different deep coads looks to compared to pretty coads.
Oh, that's a great question. Would someone else like to answer that?
The differences between the pretty coads and the deep coads are that the pretty coads do not clip the spike mask. So you'll see that the diffraction spikes are maintained. They also used a not global, but per visit background estimation. So more of the larger scale background is maintained. You can look at the difference between the GRI HIPS map, which is the so-called pretty coad. The single band HIPS maps are the true deep coads. Those are a better representation of the actual pixels that the object catalog was measured from. So this is a somewhat experimental feature, but if you read in the deep coads from the Butler, there's a extra piece of information in them, which is the difference between the pretty coad background and the deep coad background, a model of it. And you can add that model back into your deep coad to make it look more like a pretty coad. This has not been extensively validated. So I'm looking forward to folks poking around and looking at whether or not when they do that, it looks somewhat like the RGB HIPS or not.
you want me to read the online ones?
No, Yusu's in charge. We can go to another in-room question while we're vetting the online ones.
Hi, I have worked on DP1 a little bit and I might have missed this part, but I'm curious about like the band coverage there. Because I know when I was working with DP1, some of the spots were missing the bands. So in DP2, like would most of the data have all bands or is that still?
No, it's still some fields, some regions have all bands, but all regions don't have all bands. So if you go to actually to data preview to like dp2.lsst.io, there's a page under overview that's called observations, and it has the number of visits per filter for each of the special fields and overall. So that's a good place to get started if you did only want to look at fields that had all 6 filters or something. Yeah, start there.
Right here.
Oh, great.
Is there an estimate on when early DP2 data will be available and on the brokers?
It doesn't go to the brokers.
Okay.
Only alerts stream to the
Okay.
brokers.
Okay.
And alerts are from the prompt products,
Mhm.
which you're about to hear all about in a
Okay.
moment. So,
Thank
yep,
you.
yep. We'll go there.
When I saw your limit of ellipticity of 0.2, I was curious to know if there was any anti-correlation of the seeing and the PSF size, as might be the case. Pardon? The image has an ellipticity. It also has PSF. And in my data, the highest detectability also has very high ellipticity because you're seeing effects.
I have not looked at that. Oh, did it?
Michael says the answer is yes.
Maybe can we, yeah, give the mic to Aaron for a second. Yeah. Thank you.
I'm not going to answer it. I'll just say there's a session on Wednesday morning devoted to image quality. I think the organizers are, based on the questions that have come up already, are going to reserve time for questions from the assembled folks. So maybe we'll delay that question until then.
We'll get those into that session. Okay. And then I think, yes.
Thanks. Two very brief questions. First, could you go back to the limiting magnitude map of the coads, maybe 3 slides back? A little bit. Yeah, that one there. The regions around that are greener, that's just because there are fewer images. Oh, you just hand just shot up. So I guess you can have the answer to that question. Yeah.
I want to hear the rest of your question.
Well, no, it's okay. So they're just fewer images, right? And is that a product of the cell-based co-adding, or is that completely unrelated? Because the cell-based co-add sounds awesome to me. Like it's the first time I ever heard of it. I think it's like almost magic how it's improved from DP1. But could you give us a little bit like about that?
Okay, you're asking why around Elias, for example, there's a clear LSST focal plane, and then the footprint extends beyond it, square shaped.
Precisely. Yes.
Okay, I understand. Okay, so we co-added every single tract, and a tract is a pixelization of the sky. This is the so-called sky map that Melissa was talking
Right.
about.
Tracts and patches. Yeah.
The sky map has the same tracts that were used for DP1. So if you had a favorite tract in DP1, it'll be in exactly the same place and the same size and DP2. The only difference was that the cells are different. But we co-added the tracts that were touched by a visit that was taken before the shutdown in September.
Oh,
So around the deep drilling fields, for example, only the deep drilling fields were observed before September. However, there was observations taken afterwards between October, November, December, and those are the visits that are extending the deep drilling field to
cool.
a square
Okay,
shape.
so that's value added to those spaces, not subtracted.
Yes.
That's awesome.
The,
Thank you.
the extra dithering helps with the artifact rejection and the coads quite a bit.
That's great. Okay, both my questions were answered. Thank you so much.
There's two. Say these out loud. So I think Eric, you're going to cover this later, but the question is, will the BigQuery version of the PPDB allow solar system source queries? And then the second one is, for those new to Rubin and the text documentation, the text documentation is helpful and can be less overwhelming than looking at notebooks. What is the timeline for completing the online DP2 text documentation?
Okay. The timeline to complete dp2.lsst.io, complete. We are always learning new things about it, and we're updating DP1 documentation like a month ago. So for end, but over the next 2 months is kind of our busy time. Now that we have the data in hand, it's a lot easier to write the documentation for it. So I'd say hoping that we get there like within the next month or two, but we never stop. We always try to make it better.
So this is phenomenal. This is a really great milestone, I think, for the entire project. I'm sure over the next couple of months, as people start using this, they'll start finding bugs. How do we all, how do they get back to us? What's the best way to report things?
The best way is always the Rubin Community Forum in the support category. That is where Rubin staff monitor that category, and every single new topic that gets posted there is worked through to a full solution. Where we open internal work tickets to make sure that the work gets done to fix those things. And then we always report back, mark it as solved. So that is like the #1 best place to go for feedback. If you are a member of a science collaboration, you have alternate options as well. So there are data management liaisons to the science collaborations that are happy to take your feedback that way. It triggers basically the same internal process where we talk about the issue, we open tickets to do work, and then we report back. But the forum is always the best and most open way. I think we can switch over to prompt products now. Let's do that. Yeah, thanks for all your questions, everyone.
All right, thanks. I'm Eric Bellum. I'm the Alert Production Prompt Products Group Lead. We just heard about the early science enabled by data releases and data previews, especially EDP2, which is just out today. And congratulations again to Frosty, the data production team, CST, who have been really, I know, working extremely hard over the last month to get that out to you. I'm going to talk about the prompt products, which is the other thing that we have released so far. And so, as you know, back in February, we started releasing public alerts to the 7 alert brokers and the 2 downstream brokers. This is just a screenshot of the dashboard we were watching as the first alerts went live. We had a little group there, and we're very excited to see everything coming up flawlessly. There is a dashboard that you can access, ls.st/alertstreamstatus. That has live information about the alert production pipelines, and when we are back on Sky, you can always check and see if Rubin is producing alerts right there. So alert production requires co-added templates to compare against. And so we have deployed a set of templates, both from commissioning observations of many of the fields that you saw from the DP2 slide, as well as a section of that broad wide area that was covered in DP2. The coverage varies pretty substantially by band. We've got a little over 1,000 degrees in I and Z, and less in the other bands, just based on where the images were taken. But nevertheless, that gives us enough for a reasonable amount of alert production when those areas of the sky are visited. And so this is the histogram of the numbers of alerts that we've produced to date. Starting in February, the first alerts nights were extremely high because we just sat and stared at 3 deep drilling fields all through the night, which is not the usual method of observation, but was a great stress test for our systems and I think the brokers as well. And then we almost immediately switched into a period of engineering where we did not take mini science observations at all, and so therefore the alert rates were quite low. That started to ramp up again in sort of the April-May timeframe, and then you see spikes as we deployed the wide area DP2. We got quite a few more alerts, and so we're sitting sort of comfortably at a little north of 500,000 alerts per night on a good night these days. So from here, we need more templates to get more alerts. I'm going to actually skip through this slide because it's very text heavy and sort of talk to this. So these are a little too small to see, but they are they're a map of where Rubin has observed since LSSTCam was first put on. So this goes all the way back to the start of commissioning. And the color background is showing you how many images are taken at that location, with blue giving you kind of 1 image, and then through white at 5, and then red at 10. And if we're trying to get templates that don't have gaps, we need about 3 images input, so we don't have holes. And so the green areas are areas where we can sort of hope to perform co-addition of these existing data in order to make new templates. And so again, that's combining potentially pre-LSST observations, commissioning data, and so on. We've already gotten a lot of the juice out of the DP2 sort of area. And so if we look at what that looks like on Sky, you can see that depending on the band, there's anywhere from 2 to maybe 5 times more area that we can hope to produce templates for using what's on disk right now. And so that's okay, but not amazing. That gets us to a little less than maybe 8,000 square degrees in Z-band if all goes well. But that's what we have available right now. So what we're trying to do is sort of validate the process of choosing the sky areas where we think we have images, and then selecting those images, co-adding them, validating the co-ads are science grade, and then putting them into production. So that's the work of the next month or so while we're off Sky, is to get this another tranche deployed and sort of validate that pipeline. Elsewhere in prompt products, the prompt products database, or PPDB, is a relational. Well, it's not. It's a database view of the alert data. So there's not really any new information there, but it's provides a way to query the data in a way that in some cases is maybe a little easier to work with than if you're not trying to listen to a real-time alert stream. So the baseline technology is Google BigQuery, and so we're working now to put the front end on that to make that user accessible and queryable in sort of the early fall timeframe, and that will give you the ability to do ADQL queries on DIA objects and SS objects and retrieve light curves and so on. So look for that in the early fall. There is a documentation site, as with so many of our products, prompt-products.lsst.io. We continue to improve it and update it, but all the information about data processing, pointers to tech notes on things like the reliability score, known issues, citation information is all there. I encourage you to check it out. Similarly, the CST has produced, the community science team has produced some excellent tutorials about using various services, both using things like the alert retrieval service, which is accessible now in the portal and through the notebook, as well as pointers to the brokers and so on. There is also a link here to the live status page, which can tell you more about not just the alert stream, but the planned and executed Rubin schedule, all sky cameras from the summit, nightly summaries, and so on. So if you're curious about what Rubin is doing and how you might want to observe yourself, this is a useful collection of resources. Finally, we have executed some TO observations already during the primary LSST survey. So there's a set of TO triggers that are understood and sort of accepted by the project, including gravitational waves and neutrino events, galactic supernovae, and hazardous asteroids. So there is a board that sort of monitors this, and we executed a recommended trigger on an ice cube neutrino earlier this month. That was later withdrawn, unfortunately, but it was an excellent smoke test, I think, for the process. And I think the major thing we need to work on is, getting as we have more templates available and getting more of this out through alert production. So that is all the slides I have on prompt products. So I'm happy to take questions.
Thanks. I wonder if you can tell us a little bit more about sort of the quality of those templates. As you say, there are 3, which is sort of the minimum, but I imagine as the survey continues, that the ability to make good templates and deeper templates will improve. And how should we think about that in terms of the kind of objects we can see?
Yeah, great question. I think that the message from the community has been quite clear that any templates are better than none, and I agree with that. So we are kind of pushing the hairiest edge we can as we deploy the templates. The constraints that we face in sort of thinking about template generation are a fewfold. One is that alert production has a database called the APDB, which contains all of the sort of light curve history that goes in the alert packet, and that is a system that we don't want to overload with false positives. So we have to be cautious about deploying templates that are going to create a bunch of junk. The other issues are that it takes a while for us to generate and deploy templates, both from a just CPU wall clock processing time, but also sort of the hand holding of vetting those and putting them into production. And so it's not a fast process to update them. So that points us towards a little bit of conservatism in that we don't want to deploy templates that have a bunch of holes in them, because then you're going to miss sections of the sky for 6 months, say. So what we're trying to do is sort of find that sort of very minimal sweet spot where we're not putting templates in production that have huge artifacts or lots of holes, but that get us on sky as soon as we can. And it's certainly true that in a year, in 2 years, we're going to have much better templates, and they're going to be exquisite and cover every pixel and reject all the artifacts. But in this early science phase, we just ask for your patience and dig around with us a little bit in the noise to find the good stuff. Give him a second.
Thank you, Eric. So I'm talking about from the broker's perspective. I mean, most of the brokers will want to enrich the information they show users with prompt data products, but this will require authentication. And so it would be good to have like some recommendations from the project about how we should do this in a more
You want to be authenticated so you can reach the which prompt products?
So for example, if I'm a broker, I cannot just provide information from prompt data products to all users because not all users have data rights. So
Rossi, can I give you this question? The question was, the brokers would like to be able to provide access to users to data products that require data rights. How do they handle that authentication?
All right, so prompt products, we don't have any yet. Okay, yeah, sorry. Okay, all right. I was like, did I forget something really important? Yeah, I have slept in the last week, sure. Okay, so there is a process that we have been using with the IDEX where you can use delegated authentication to establish whether a user has data rights in order to serve them the data. If you want to a user to consume data from us, it has to come like you have to. Right now, there is kind of, we don't have the ability to basically handle people using us as their service backend. It's not that we can't do it. It's just we don't have any ability to make sure that you don't slam our system and lock out individual users. So I think depending on your use case, and you really should come to talk to me, preferably tomorrow after I've slept. I think the kind of general usage here is, you provide something like a hot link to a data product or service that the user basically executes under their own, quota and authentication. Yeah, it's hard to answer this question. Sorry, I need an actual walkthrough of exactly what you mean. Yeah, Mario, go ahead. And talk to me as if I'm 5 right now.
Yeah, I think if I understand Francisco well, it's more of a question, if we have our enriched Rubin, let's say DP2 products that are still effectively can only be served to data rights holders. How do we find out if somebody visits our website? If they're a data right holder?
I see. Yes, no, that is absolutely the IDEX use case then, which some IDEX are already using. There's a document, basically, you contact us, we give you a token, you use it to talk to your authentication system, and you basically say, does this person has data rights? And the system replies.
That's wonderful. And do you know if that's already in place? And how long does it usually take for that loop to close?
It just doesn't take much time at all. It's a very simple process. So there's a document, there's documentation. I can send it to you later. But yeah, there's an RTN whose number, DMT. There's a document. But basically, you post on community under the IDEX forum. You say, "Hey, we'd like to check for user data rights." Melissa says, "Yes, these people are real." I mean, I know you're real, but sometimes people and institutions whose name we don't recognize ask, and we wait until Knut, I think, checks them out. Is Knut there? Yeah, Knut is there. And then Knut says, yes, these people are legit. And then we give you basically a token that you can use to basically say, does this person have data rights? It's, by the way, thank you. Okay, I'm starting to swap all that part back into my brain. So it's actually very important that you do that if you have a service that actually serves users, because there's a fairly complex logic as to who has data rights, because the data rights are per release. For a user. So, if you had data rights for DR1 and then, you go and live in a place that the US considers a bad place and you lose your data rights, you still retain data rights to the release that you had, you just don't get any future data rights. And so theoretically, we keep track of all of this. We will by the time we get to DR1. So it's always worth checking that somebody has data rights. So instead of just assuming, let us do the work and do that. And I think 3 IDEX Knut might remember better, but I think at least 3 IDEX are doing delegated user authentication right now to us. So pretty sure it is working. At least nobody has complained. If things don't work, you should complain. Otherwise, we don't fix them.
Thank you, Frosty. Online questions? I think we have one slide left.
Thanks. The target of opportunity thing is very interesting to me. Is there detail in the Pub 201 about, for example, how the members of the committee deliberated or the pattern stuff? I can read it there, but if there isn't, is there some general sense of like when you said it worked well, like did it work like well with the human sort of intervention with the
Is Igor in
TO?
here? I want to delegate to there's Sean. There's
Yeah.
Sean. We'll make Sean answer. This is Sean McBride, who's been making all the TO stuff work soup to nuts.
Hi. So worked well. I would quantify worked well as over the years, we've defined a set of both triggering criteria and observation strategy that we would like to employ in the event of alert class 1, 2, or in this case, high energy neutrino. For this first TOO for the LSST during the LSST period, we followed the trigger criteria that we have set out beforehand, and we followed the observing strategy that we identified beforehand. So everything worked in very much a standard sort of modus operandi. There's still, it's early science, so we still have some ways that we can optimize things, particularly on the image processing and information dissemination side. But I think for our first activation of the TOO system, this was a large success, even if it turned out to be muons associated with a cosmic ray shower. So.
I wonder if you can say a little bit more about the alerts themselves. And then you made reference to false positive rates and so on. Tell us sort of the things that are not going as well, or yeah, maybe the false positive rates are so small that they're not interesting, but tell us more about
that. Not that, unfortunately. There certainly are classes of false positives that we're aware of and are tracking. One of them that has come up that was the brokers noticed and pointed out to us. So those wide area DP2 templates, some of those, the dithering pattern and the image quality was such in the inputs that you end up with relatively sharp PSF transitions in some of the chip gaps. And so we can see excess alerts in sort of a grid pattern there. They're not at a large enough number that they're a threat to the APDB, and so we elected not to take them out. But we do see artifacts of that kind, and that sort of highlights a little bit of our caution around just YOLOing templates into production, because you know, there are issues like that appear. I would say that we are continuing to improve our reliability model. You can hear Tatiana talk about that in the alert section tomorrow. We are, I think, least performant right now on variable stars. Transients, asteroids, I think, are both pretty good. They get nice high reliability scores and are pretty pure. But we're continuing to improve the training there bit by bit. I don't know, Ian, is there something I'm forgetting? What else are we working on? I don't have numbers for you. We've got an AP paper that we're working on, and that will all go in there. We've recently done a fairly large round of source injection on some of the first alerts data and show that we're getting fairly good completeness. Ian is working on some deblending that you'll hear about in the science pipelines talk. There's a small fraction of, for instance, solar system objects that get lost because they're next to a real variable source. And so we're going to handle that a little better, and that will boost the completeness there, and similarly for other kinds of transients and variables. So I think at this stage for alerts, you know, we're just in a process of continuous improvement, and the more folks use our data and find and report things to us, we'll chip away at it as we go. All right, let's go to the last section here. When will early science just become science? Data release 1. Do you want to speak to it?
Sure. Yeah. So, okay, how about, yeah, that's better. Yeah. Okay, yes. Right. So 1 year of LSST observations takes 1 year to process. We can nominally expect DR1 to come out in the middle of 2028. One of the common questions that we get about data release 1 is, will it include data that was not in data preview 2, but was taken before the start of the LSST? Because does some time there. Data preview 2 is up to January 6th, and then LSST didn't start until end of June. So there's that time in there. The main message is that data will be released, but maybe not as part of data release 1, maybe separately. The recommendation of exactly how to approach that data and how to release it will be made later this year by the Data Release Board. They consider all the factors, the data quality, the science impact, the data services that are available, staff hours that are available, and then the Data Release Board makes a recommendation to the directors, and the decision gets made that way. But you will get it one way or another. The other question that's often asked about data release 1 is, will the data releases always be calendar driven? Are they just going to forever be, the year after the end of the last year of survey, basically? And that is currently an open question. There is a proposal right now that's open, at least internally. Within JIRA as a project, we use the request for comments process to raise proposals and have discussions and make decisions as a team. And so a proposal for a science-driven criteria cut for data release 1 has been put forth. It is basically this: once we have reached the nominal year 1 depth across the sky and obtained enough images to both calibrate the first full sky data release, calibrate photometrically and astrometrically, and to generate templates that cover the full sky. So the proposal is that becomes the criteria for when data release 1 comes out. And that's kind of where we want to end today. We want to end with like a little reminder that weather and other events that we heard about this morning are beyond our control, and we can only respond to them as they happen, and kind of open up the floor for discussion on how this might impact your science, and just sort of hear from you in the last couple minutes of this session. So floor is open, and we have mic runners. Have a think. And we'll take comments and questions. Yeah, Tesla down front. Steph, can you?
I don't know if this is a question as much as a comment. So in terms of like considering giving feedback on this question of like, what is DR1? Various things get conflated in like, are coupled to what makes sense there. So for example, when would we start rolling? And, is there some, like if we delay to get the uniform DR1, is there a possibility of putting out some of this other data sooner? Because we have more time and maybe we could squeeze something else in. So, that's just to say that like, at least I kind of go around in circles in terms of like my thinking, because some of these things go together.
That completely makes sense, as there will be trade-offs. This is only the very start of this discussion. So any feedback you give today, that's probably not your last chance. I would imagine the science collaborations, you will probably want to organize them into providing some sort of what the trade-offs are. Yes. So we could start there if there's something in your mind that's like the most important thing to know about these options. Maybe we could start with that. Maybe it's too soon. I just want to think about it.
A lot of things also depend on when we go on Sky again, right? Because then, then it also like, what does it mean to have the full thing in like all bands and, all of that, but I guess, to me, the rolling question and how that couples to this decision and the options around that is definitely one of the factors.
For rolling, and so anyone can chime in here. It was my impression that rolling doesn't start until year 2 is started.
Yeah, but yes, but that's the thing is like the idea was that year 1 was also a uniform thing. So if year 1 is a calendar release and it's not uniform, you don't necessarily, and also if you don't have templates, are you getting alerts anyway? And so, right. So like, that's I don't know if rolling either goes on a calendar schedule. You see what I'm saying?
I do see that there's the survey being driven by calendar or metrics, and then there's releases being driven by calendar or metrics. They might not be the same.
I mean,
exactly.
I would say, for example, for a lot of science, it's important that we have some release that is uniform.
Okay.
Before rolling starts.
Which is, I think, a feedback that we've heard.
But you also want to start rolling as soon as possible for all the transient science. So like once you have templates. This is my problem.
And just to add to that, because desk is one of the heavy drivers of where we want uniformity, the uniform co-added data release doesn't have to have the same sky area as everything else. So we could tolerate a reduced sky area. Obviously, we'd like as much as possible, but given the constraints, I think we'd be happy to settle for cell-based coads over as large an area as possible, while also building templates. It does seem like there's going to have to be some survey cadence optimization work here, right? Because a lot of this also does depend on whether the downtime from the weather is 2 months or 3 months or hopefully not more, but how much of the sky are we missing?
I see. I think you're saying too that like this part is kind of up for debate also, whereas maybe you just need some sort of completeness over some usable area. Yeah.
Yeah. Okay. I think this is on a similar theme. I mean, a notional idea, but this may be practically impossible, is as it were defining a small area with reasonably deep, reasonably good seeing that would fill some of the role that the original conception of DP2 might have filled. Right? The original thought early on was that DP2 would be very much survey-like, but the image quality wasn't quite as good. And for a lot of the science, really good image quality to practice on is a good thing. And so anyway, this may be impossible, as it were a DP DR 0.5 over a modest area, but this may be out of the question in practice.
Right. And to follow further on what Michael is saying, in the spirit of having something small, but already having it, as opposed to waiting for something that's the perfect, which might be the enemy of the good. Although we would love perfect, sometimes good is good enough. I'm thinking grandly back to my student days when the Hubble's spherical aberration was first detected, and there was actually discussion amongst us old farts about whether or not we should actually just release the blurry data, or should we not, and then wait till we can fix it. And the idea was to release the blurry data, and we got a lot of good stuff out there, but it was still science that sort of was a stopgap until the first repair mission happened, and then we had these wonderful images that are on all of our screensavers, right? So if this shutdown turns out to be that problem, I know it's fundamentally different in many things. For example, software development for the data reduction timescales and so forth. But if we could get just the data from the start of the LSST up to the time when we have not been able to observe since, is that a small increment of time that is a stopgap? And then that could be called like DR half or DR quarter and then go beyond. I don't think that's possible, but what kinds of ways can we think about to make a DR1 in stages so that we get DR1 the way we want to eventually?
I love the idea of trying to get data out to people incrementally in stages, but that's really, I think, not the plan, to have like DR1, Q1, Q2, Q3. I think that's not
Yeah,
happening.
if that's not feasible, then that's not
Yeah,
worthy discussion, but it's just a thought that, you know, we've been considering.
it's a good thought, but I think that's pretty much off the table.
So I very much sympathize with that, and but I also sympathize with just how difficult this is. So I think a middle ground is, I believe the project is planning to start releasing data essentially in real time, but more on the raw level. So raws or easily processed data. And once that starts streaming out, you know, many of us here know how to run SExtractor. We can get some science out even if we have to wait for a couple of years to first data release.
That's what Eric advertised prompt. Yes.
Sorry. Not only will we release prompt raws, we'll also release the processed visit images and the direct source catalogs that Ruben has done its processing on. So if you like Source Extractor, that's great, but we will have already generated catalogs for you on those data that you can use right away, and you don't have to touch the pixels. Coming October to December of this year.
Okay, sorry.
This is Bob, for those on Zoom, Bob Blum. I just wanted to acknowledge that we have also heard from folks in the community that predictability of when we think things can come out is an important consideration, especially as we roll into multiple new proposal calls and things. So we're certainly thinking of that as well. And that will definitely be rolled into this discussion.
I have something I've always been curious about. So I guess the model is, we take the first year of data for DR1 and then you spend a year processing it. Is the reason that you wait to start that processing so you have a consistent set of software, or have you been processing the whole time? How does it, so really took 2 years? How does it actually work?
All the processing that is parallelizable by detector is done during prompt processing. So yes, we are constantly processing the data, and it has another name, prompt processing. The data release production, the reason it has to be done all at once is because after single frame processing, the next step is the global photometric calibration, and that requires compiling all the data that has been taken to date and processing it together on one node.
Sorry, I want to add something to something that Bob said, actually. So we're trying to keep everybody happy. It's if everybody wanted the same thing, it would be easy, but they don't. So the two tensions here in terms of like releases and capabilities is the predictability versus the timeline. So if the community, what really they want is predictability, like the timeline will be longer because we have to give you an estimate that we are guaranteed to make, to be able to reach, right? So if it's like less, if there's less pre-commitment, things might actually like come out a little bit faster. So so it's a bit of a trade-off, but we do realize that people have to line up students and grants and so on. So overall, the theme has been predictability. So with early DP2, I was told like a minimum of 4 weeks notice was required. So that's why you got 4 weeks notice. But yeah, some of the stuff comes out sooner rather than later, or later rather than sooner. And it's difficult to know until you close. So just bear in mind that those sometimes those desires are in tension with each other. It looks like it has been.
We still have a bit of time, so we've heard a lot maybe from more senior members of the community. Are there any junior members of the community that have opinions on how this decision might affect their science and they would like to chime in? You're being specifically invited. Okay.
Thanks. So I'm a grad student. A lot of my work is really focused on the deep coad products. I have to say that the idea of a like science-driven cut for DR1 is appealing. I think that it like it does raise concerns because I just passed candidacy and I had all these really cool ideas for doing stuff with Ruben. But I think that like it's better to take the time to like make sure that it looks good and that we're doing things in a smart way. And then I also would like hate for a lot of the like pressure for release to get placed on like colleagues right now in Chile who like are dealing with some very serious stuff happening. I don't think that like we should be worried about trying to get data out or get things back onto the sky. There's other important things that are.
I guess, how would you determine like what percentage of the sky counts as full sky if, for example, like some period had some relatively short period of observability and there was bad weather during that time, you'd have to wait a full year to get back to it or something like that?
That's a good question. I think that's kind of also what Gotham was saying, is maybe that all sky isn't necessarily needed, but we'll have to look to the science community to maybe define how big is big enough to go forward with year one data. So that's a good point as well. Yeah. More comments to add on those? More junior perspectives on early science? Yeah.
Question about the astrometry then. If we are defining the cutoff for year one to be a photometric depth, do we also consider how much of the sky has well measured proper motions or parallaxes, or how far, how deep those go as part of our criteria for stopping?
Those are good additions. Yeah, thank you. Yeah, I think the answer is unknown right now, but if that's important, then that's something we should consider. Yeah. Oh, is there one over there?
Hi, this is Shreya Anand. I'm a postdoc at Stanford. I just wanted to second what Gautam had said and others have proposed in the past of maybe a slightly downscoped version of this without necessarily the full sky, but even a smaller patch, as it would be very useful, specifically for the target of opportunity science cases, for which we are petitioning for deeper exposures and for which deeper templates would be extremely useful and enabling of various science cases and also of various transient cases, but I'm specifically speaking with my TOO hat on.
Any final things anybody wants to add for our consideration? Anything from online? If Leanne has joined us on Zoom and wants to make any final comments, this is Leanne's proposal. So I'm going to invite her to unmute and say anything she wants right now.
Hi, Melissa. Thanks. I am here on Zoom, but I don't have anything else to ask unless anyone has any questions. Just happy to take input, various different perspectives to this proposal.
Okay, Meg, go ahead and unmute and ask your question.
Thanks. I wanted to ask about, I guess I don't quite understand the two trade-offs we're looking at. Can you hear me?
Meg, if you're speaking, I'm sorry, we don't hear you. Okay, so there's something wrong with the speakers in the room and we don't have our person to help us troubleshoot that. Sorry about that, online people. I invited you and then we can't hear you. Charles, go ahead.
I did ask for sorry, this has become a conversation, but I do appreciate your ask. One thing that we haven't talked about in this conversation is what external, not from our science community, but from the rest of the world community needs us to produce, right? I know that there's some delicate things that we have to walk about funding agencies and things like that, or foundations and things like that. But what do they have they chimed in? Are they even aware at this point that we have to be thinking about these things that may delay, say, at least for a full year, our entire first new data releases? Are those pressures things that we have to consider on the science and the engineering side? No.
The agencies are remarkably good at declaring defeat victory. So no, they will say that it's wonderful whatever you do.
Is there a rebuttal to that? I'm sorry. I don't want to put anybody into any uncomfortable position. So maybe we can just stop that line of conversation right there.
We're not talking about a potential year-long delay. And I'm also not sure exactly who all you mean by outside of scientists, if you mean the public or the agencies.
I kind of think both. The public, the people that I speak with, I just gave a public talk about this like 2 weeks ago, actually. They're thrilled and excited, and they already think that Rubin is done, because First Look was so beautiful. They're like, wow, this is great. Can't wait for the 5 million asteroids we're going to discover, 3 weeks from now, kind of thing. Right. And they're being put off for a longer period of time. And that's not as big a deal, because if they're disappointed, we don't lose funding immediately. But yes, agencies are an issue, but I understand, again, we can't really talk that much about agencies right now, but the issues of since we live in the real world, do we have to think about real world constraints in addition to ideal science constraints?
Today, we are just asking you to think as scientists, what is best for your science, and just leave it at that, I think.
Fair enough. Yeah.
Meg, I'll read your question out loud and then ask it. Or answer it. How about that? So Meg asks, can you talk about the trade-offs in terms of processing times? Last year, we couldn't have a 6-month data release because of compute and human power. Is there a way to estimate how long it would roughly take to process, validate, document, release any x squared degrees of LSST data? Why would it be possible to process 6 months of pre-LSST, but not possible to make a 6-month data release instead of a pre-LSST data release? What am I missing? Okay, so what you're missing is the phasing. So remember last year at this time, the plan was to start the survey in the fall, which would mean that the first 6 months of data would have been complete by April of this year. April of this year, we were still processing DP2, and it would have been, I'm 100% sure it would have been impossible to start processing DR1 while we were still processing DR. DP2. That was just impossible. We are still phasing now. So we are working on EDP2 now. We're going to work on the prompt products database and serving that next. Then we're going to work on serving the visit images and the difference images and the RAWs from both the prompt products and the alert production and also from DP2 for the full DP2. When those are done, then we can start working on what's next. Like Eric said, the processing priorities for the next year are going to be incremental template generation. Incremental template generation can look like the tasks, a lot of the same tasks are part of the data release production pipeline. So it is not outside the realm of possibility to include to release some of that as our preferred method for releasing this pre-LSST data. That is an option. Another option could be including it as part of DR1. Remember that the data that you include in the COADs does not have to be exactly the same as the data that's included in the data release. And you saw that in DP2 as an example for that. There's the 30,000, not all of the 30,000 visits were included in the COADs. As far as the rule of, or how long to process, our rule of thumb is that it takes roughly, okay, so for DR1 amount of data, it would take a year. And so in this early science period while we are ramping up and before we buy more hardware for DR2, DR3, DR4, the rule of thumb is that it takes as long to process the data as it does to take it. So 6-month data release would take 6 months of data would take 6 months to produce a data release. Year's worth of data would take approximately a year. There's big error bars on that, and we have models, and I can send you the processing model for DR1 if that is helpful. Okay, I think that's it.
I think we could do one last in-room question.
I just wanted to make one comment in response to what Charles was saying. So there probably is one thing we might want to think about. Somebody like Gautam could maybe speak more to this, but there are a fair amount of discussions happening with other collaborations, like the CMB experiments, spectroscopic experiments, the space-based experiments where people are doing things like writing MOUs, and there are certain expectations about when things are going to happen and when people will do things on the other side. So at least not necessarily that any of these things would be inconsistent, but there probably does have to be some certainty there because some of those people are also promising to do things on particular schedules.
That makes a lot of sense. That's a good point. Good point. Thank you. Okay, we are at 90 minutes. Thank you so much for joining us for this breakout session, for engaging in the discussion, and enjoy EDP2. Stay here for the next session if you want to learn to use the RSP. Yep.